Hi class, we're going to take a look at section 4.3 today, but before we do, as usual, I have a warm-up for you. So if you haven't already done so, take a minute to do the warm-up, pause the video. And when you get a chance, let's take a look at the solution here. Honestly, even if you haven't taken a chance to do it, what I'm about to show you isn't going to be much help. I'm just going to show you the answer, and I'm just going to assume that you'll use the knowledge from the previous section to find this solution for the first one. And I will just give you kind of talk through some of the details of this, but I haven't obviously shown a lot of the work here. The characteristic equation, of course, will be r to the fourth plus 81 equals 0. Then you'll put the 81 on the other side. It'll be like negative 81. So I guess we're looking for kind of the fourth roots of negative 81. They're in the complex plane, so we're going to then represent negative 81 in polar form. It's 81 is like the r value, and theta would be pi. Like kind of just intuitively, isn't negative 81 the number that's 81 units in like to the left, in the pi direction? So 81 cis pi, I guess, if you're using that kind of polar notation. And then using de Moivre's, we can just take that to the 1/4 power. 81 becomes 3 when you take it the fourth root, and then the pi becomes like pi over 4. So that's like, but that only gives you one root. Now that's here, you can see it here. That gives you kind of 45 degrees in the first quadrant, right, in the complex plane, 3 units out. But then as you go to find the other roots, you can just add 90 degrees to that, or pi over 2 radians. So then you'll have kind of all the 45-degree angles in all the quadrants, right, is where you'll end up. And then now you have each of those, you take the cosine and the sine of, using Euler's identity and all that stuff that we've done before, and you get the 4 solutions that you see here, the 4 linearly independent solutions that you see here. I don't know, that was a pretty quick way of saying it just out loud, but I hope you remember kind of how to go through that. The details are in our previous lesson. Similarly, the next one I'm just going to kind of show the solution for, but I've already kind of helped out by saying that the characteristic equation here, actually, honestly, I think you could probably have figured that out yourself, but I'm kind of helping you out here, that it does factor in that way, r squared plus 1 cubed. So it has the roots plus or minus I, but then of course each of those has a multiplicity of 3 because of that third power. So with that in mind, what would you normally have for plus or minus I? And the answer is you'd have like c1 cosine and c2 sine of t. But then since we have like a multiplicity of 3, we really need, like, this is a 6th order equation, we need 6 constants. So you're going to have that, but then also times x and also times x squared. So you see those 3 kind of parts there to take care of that repeated solution. So just to highlight again, notice that this is normally what you'd have if we just had roots I and negative I. But then since they have multiplicity 3, we have those things also times x, and those things also times x squared. So today we're going to take a look at 4.3, method of undetermined coefficients. And the lesson is simple today. Here it is. This is the entire lesson. The method of undetermined coefficients is exactly the same as it was for second order linear differential equations. So really, I'll walk through one example carefully, and then the others this will be a short lesson, and then I'll just give you ones to try. Although I should say this, it's a short lesson for me to do this video, but for you, it might take an hour because you're going to work through, I hope, each example and then just check as the video plays. You'll pause and check whether you got what I got. So let's solve this IVP. Certainly the characteristic equation for the left side there will be r cubed plus 4r equals 0. We're going to find the homogeneous solution. That factors nicely, and it gives us these roots. So we got our 3 roots, and we can write down our characteristic equation for the homogeneous solution. C1 plus C2 cosine 2t plus C3 sine 2t. I'm rushing through these details because we've done that in prior lessons, and I think it's pretty straightforward there. Okay. Now, we're trying to find, we need not just the homogeneous solution, but we need like a particular solution so that we get t on the right side. Right now, if you plug that thing in to our differential equation, the thing you'll get on the right side is 0. but we want to get t. So let's now use the method of undetermined coefficients. We know for t that our UC set will be t and 1. And now in this case, we need a revision of our UC set because we noticed that that would produce, our UC set would produce a constant, which one of our solutions is a constant solution, the C1 right here, right? So there's this overlap I should have highlighted on the slide. Maybe this is overlapping with this in the UC set. That means the whole UC set needs to be multiplied by t. And now we're prepared to set up the form of our particular solution. It'll have two unknown constants, a and b, times the things in our UC set that we have. We're going to need first, second, and a third derivative as we go to plug those into the differential equation, the original differential equation. So let's do that now. The original differential equation is doesn't make this a super hard task for us. We get 0 plus 4 times 2at plus b, right? And now we correspond coefficients. We're going to have an 8a, that's our coefficient on t. And then a 4b, that's our constant term, which needs to be 0 because there is no constant term appearing on the right side. So we get that for a and b, and we can finally write our general solution. But notice, because the thing was given as we started this problem was an IVP, we're actually not quite done, where you can't like put that in a box yet. But we're making great progress. We just need to apply the initial conditions now. So I'm going to clear the board. Okay, so here's the equation that we just got as our general solution just a second ago, and now let's apply the initial conditions. So what we're going to do is start with, I color-coded the initial conditions, so we're going to plug in 0 for t in the right side here, and we'll make 0 be the left side over here, and we also need the first and second derivative to apply the other conditional conditions. So doing what we just said in red gives us this because C1 is there. C2 times the cosine of 0 is going to be 1, and all this, when we plug t in, will go away. With the second initial condition, the blue one, when we plug 0 in here, we're going to get 0 on the left side, and we'll get, this will go away. This will be the only term that remains. Cosine of 0 here will be 1, so 2c3 will be the only kind of piece of that remains. And then last, the purple initial condition, the second order condition. If we plug 0 in here, we're going to get, this will go away, the sine term, and the cosine term will be negative 4c2, and now we actually do have a 1/4 to deal with as well. And on the left side, we've got a 1. Solving these, the second equation gives us our C3 value. The third equation just immediately, the purple one, immediately gives us our C2 value, just solve for C2. And then we can go back up to the first equation with our C2 value and find that C1 is, of course, C1 equals 3/16. Now we have the particular solution, and we can take the we can apply the initial condition to the general solution here. So we're plugging in here, C1 is 3/16. The cosine constant here, C2, was negative 3/16. And C3 just zeroes out, and then we have the 1/8 t squared. So now this is just an opportunity for you to practice here. Give this a try. I'll give you kind of some of the rough details, but feel free to hit kind of pause along the way. I'm not going to go through every piece of this. In fact, I'm not going to go through the solving of the constants in particular. So I'm just going to kind of skate over the details, pause as you like. So here we go. We have another find the general solution equation here. Obviously, this is going to have we're going to have to find a particular solution to get all that stuff on the right side to appear somehow. But let's start with, as usual, the homogeneous solution. On the left side, we've got that cubic as our characteristic equation. We're going to need to figure out how to factor that, so let's use the rational root theorem to make some good suggestions. If we have any hope of factoring this at all, then what might be a good list of easy guesses? Well, how about plus or minus 1, plus or minus 5? Try these with some synthetic division. You'll find pretty quickly that r equals 1 works. And now we'll go over here and do rewrite that using the division, using either synthetic or long division. Write out what the quotient is, r minus 1 times the quotient that you got. Continue to work on that quadratic now. Now, that doesn't factor real nicely, but either using the quadratic formula or completing the square will give you the following roots. Again, please, along the way, pause the video and work at these details out for yourself. I don't want to bore you with the details, though I know all of you are capable of getting those solutions. So now we have our 3 roots that we need for that cubic, and we can write down our homogeneous solution. There it is. Just take a look at it for a second and verify that that's what you would have written as well. And now we think about what the form of the particular solution would be here. So we've got a bunch of little pieces to this. We've got the sine piece, so we've got, like, we need a sine and a cosine term. But then we've also got the x squared plus 3x plus 7 part, so we need like a quadratic thing. Now remember that normally we need to kind of also consider revision. But notice that there isn't, in this case, any overlap between the homogeneous solution, look at it in red, and the suggestion we have for the form of the particular solution. So notice that those don't overlap at all, and so no revision is necessary here. And so now we solve for the constants. That's the part that I'm like letting you do. That's 5 equations and 5 unknown variables, so you'll figure it out and see if that's what you get. So take a second to work this one out on your own. Pause the video. Okay, so the homogeneous equation has this as its characteristic equation, r to the 4th minus 1 equals 0. If you move the 1 over to the right side and think about what the 4th roots of 1 are, they are plus or minus 1 and plus or minus I. Those are our 4 roots, and so for a homogeneous solution, we have this in red. So c1 e to the x, c2 e to the negative x, those come from our plus and minus 1 term, and then the plus or minus I give us the cosine and the sine part of the solution there. Now the particular solution, if we're going to go to do the undetermined coefficients method here, is going to be that ax plus b, that comes from the 3x part of our right side, the non-homogeneous term over here, has this 3x, so we need that ax plus b. Now the cosine is going to normally produce like a c cosine x and a d sine x in our particular solution. But do you see what I did there? Why did I multiply by x, both of those? Do you see why? Well, notice this overlap with the homogeneous solution. So this needs the revision there. And so now we can proceed. Again, if you haven't already done so, pause the video to actually do the solving of the constants. So if you solve those constants, pause the video. Okay, and you're back. Did you get these? Did you get this for your solution? There it is in a box at the end. We've got our red homogeneous solution plus the particular solution in blue. Notice that some of those constants just disappear. B and C are both 0. On this one, maybe if all you want to do is set up the form of the particular solution here, that would be great. Like, what's my form of yp? Now you might think, okay, I can just go ahead and write that down right now. But remember that even if that's all we're doing is kind of like setting up the form of yp, we've already seen, even just now in the last example, that there could be revision necessary based on whatever the homogeneous solution is. So there's really no way to set that up without also first considering the homogeneous solution. So we really do have to work through the details of the homogeneous solution, even if we aren't going all the way and finding the solution on this one. So here we go. Use the rational root theorem, do all the things. What's your suggestion for some roots? Well, how about plus or minus 1, plus or minus 2, 3, and 6? Try each of those with synthetic division. You'll see that I've been kind again to you here, or even just by inspection, you might notice that 1 works. And as you divide that out, you'll get this. And now factoring actually works just great there. So I'm skating through these details again. Pause the video, kind of work out the rest of these details on your own if you like. We have the roots 1, 2, and 3, and so those become like our exponents for the homogeneous solution. So pretty straightforward homogeneous solution for us there. And now we can think about the particular solution. On the right side, take a look at the right side with me over here. So this x e to the x term, that produces for us this UC set. This term here with the e to the 2x is giving me this e to the 2x term, right? And all of its derivatives will be some linear combination of e to the 2x, right? There's nothing more that will become part of the solution from that. And then e to the 4x also has a very simple UC set. Now revision, remember, only needs to happen to like one of the sets that's kind of the violating set, or two violating sets in this case. I'm going to have to revise both of these sets here. This set needs to be revised because notice the e to the x is right here in the homogeneous solution. And this set also needs to be revised because notice the e to the 2x is part of the homogeneous solution right here. E to the 4x doesn't need any revision, so we'll just leave it as it is. So that was the trickiest part. Now we've got, from all those sets, we've got 4 constants to introduce. And it looks like I just forgot the letter D there, so I apologize. Can you please add a letter D in your own notes? Okay, hopefully you did. You got the same thing I did for the form of this particular solution. Now, just for fun, feel free to pause the video. And I know this wasn't in the original question. I know it only asked to set up, but just for fun, a person might want to find A, B, C, and D. So feel free to pause the video and do it. I actually have the solution here ready for you just in case you wanted to go further than that. I guess the reason I phrased this question this way is because I thought maybe it would be good to, it would just be, I might ask it this way on a test or something. I might not. There's certain ways, certain times when I just ask for that, right? So just wanted you to be familiar with this kind of question format. But if you did, just go on and solve for the constants. Again, pause the video if you want your chance to do this. Here it is. Okay, so there it is in its fullness, the final form of the general solution to this differential equation. Okay, and by the way, on all these slides, I should have mentioned earlier, this, if you look at the slides that I have on our course website, you can click on the click here for Wolfram Alpha, and the thing that will do is, as you go out to that, you'll see that it is a verification of each of these solutions. So feel free to do that. And honestly, I don't have, obviously, you can't do that on a test or a quiz, but I really don't mind you doing. When you're doing your homework or whatever, I guess you can check with our solutions. But it's not a bad idea to use technology to help you check these answers. There are some of you I know have used Symbol Lab. Wolfram Alpha will solve a differential equation of this kind for you. You can just type it in and it'll solve it for you, and you can see that you'll get this solution. All right, with that, we've come to the end of the lesson. Honestly, like I said, this lesson could have been just 30 seconds. I could have said, like I did at the beginning, just do what we've done before, right? It's just like when we were doing the method of undetermined coefficients with second order equations, isn't it? I hope that through doing a couple examples here, we've seen that that's true. And again, like the other lessons, really the challenge here probably is just the pre-calculus parts of it, maybe. So let me know if you have some questions and reach out to me, and hopefully this video was helpful. Bye, you guys.